Welcome, future automotive experts. Today, we're diving into the nerve center of any vehicle, the instrument cluster. Understanding how to verify gauges and warning lights isn't just about diagnostic. It's about ensuring safety and performance. Let's get started. First, let's talk about the two main types of instrumentation, digital and analog. Modern vehicles predominantly use digital displays, and there are a few types you'll encounter. We have LEDs, or light-emitting diodes, often seen as red, yellow, or green segments. There are LCDs, liquid crystal displays forming numbers and symbols. Think of this as the old digital clock, only on your dashboard. Then there's VTF, or vacuum tube fluorescent displays, known for their bright green glow, and even CRT, cathode ray tubes, essentially mini TV screens in your dash, controlled like a computer. These displays often use the same sensors as the powertrain control module or body control module. They receive inputs from things like door ajar, low fuel, low oil pressure, and engine temperature. Many electronic instrument clusters have self-diagnostic capabilities. Some even have a self-test procedure, often initiated by pressing specific dash buttons simultaneously. Always check the service information for the exact procedure for the vehicle you're working on. On newer vehicles, the body control module, or BCM, plays a big role. It monitors specific functions of the instrument cluster and will store a diagnostic trouble code, or DTC, if anything is out of whack. You can retrieve these DTCs by connecting a scan tool to the data link connector, or DLC. Some vehicles even display these codes directly on the instrument panel. This is where your scan tool skills become essential. While digital is popular, you'll still find analog gauges in many vehicles. When they go bad, they usually either stick in one position or register completely off the scale. Now, let's take a look at a few different types of analog gauges. Bimetal gauges use a bimetal strip that bends with current flow to move the needle. A fully grounded sending unit sends the most current, pushing the needle to the high side. If current reduces, the needle drops. Then there are thermal-electric gauges. These are easy to spot because their needles return to zero when the ignition is turned off. Electricity flows from the ignition switch through the gauge and to the sending unit, which provides the ground. Finally, magnetic balance coil gauges that use two small electromagnets. One gets current when the ignition is on, the other's current is controlled by the sending unit. The needle swings towards the electromagnet with the stronger pull. For instance, an oil pressure gauge works continuously, with the sensor's variable resistance modulating current flow to affect the coil's magnetic fields, and thus the needle's position. Now, onto warning lights, critical for alerting the driver to issues. Older systems often use a simple grounding switch. For example, an oil pressure switch closes when the engine is off, illuminating the light, and inversely opens when pressure builds up, turning it off. Temperature lights work similarly, closing the switch and illuminating when the temperature goes out of range. When checking warning lights, put the vehicle through its operating range. Be cautious with temperature warning lights. They often won't illuminate until the temperature is dangerously high. It's usually safer to replace a suspected malfunctioning temperature unit rather than testing it to its limit. Alternator warning lights are a bit different. The bulb isn't grounded at the instrument panel. Instead, current flows through the bulb and grounds at the alternator. When the alternator is charging, both sides of the bulb receive similar voltages, so no current flows through the bulb. It stays off. A dimly glowing alternator light can indicate a bad fuse or a poor connection, so check other electrical functions in that circuit. On newer vehicles with a CAN bus network, your scan tool becomes an even more powerful diagnostic weapon. You can use its bidirectional control feature to command functions, activate components, and perform self-tests on various instruments or warning lights directly. This is a huge time saver when you are troubleshooting issues. Remember, whether it's an old analog gauge or a sophisticated digital display, every instrument and warning light is trying to tell you something important about the vehicle's health. Your attention to detail in verifying their operation ensures not just a successful repair, but also the safety and confidence of your customers. Keep learning, keep practicing, and you'll master the art of listening to what the vehicle's instrumentation is telling you.